Hi, you guys. Happy Monday. So last class we talked about properties of exponents with multiplication. So when we multiplied exponents, we were adding. Today we're going to talk about more properties of exponents, but this time it's with division. So what happens when we divide? So before with multiplication, we added. So with division, we're going to subtract. So we divide powers with the same base. We have to subtract the exponents, okay? So let me just show you kind of why this makes sense. So if we say we have 2/5, or 2 to the 5th, my bad, divided by 2 squared, 2 to the 5th power means I'm multiplying 2 times 2 times 2 times 2 times 2. And then 2 squared means 2 times 2. So if we look at it kind of as what cancels out and what can we get rid of, we'll notice that we've got 2 on the bottom that cancel out with 2 on the top. So we're just left with 2 times 2 times 2, which is just 2 cubed. So all I did was I took 2 to the 5th over 2 squared, and I subtracted those powers. So I did 2 to the 5th minus 2, which equals 2 cubed. Okay, so it also works with just our variables. So we know we've got 2 cubed. I'm going to erase this so it gets out of my way. So now with our w's over here, let me just rewrite it as a fraction first. And you can probably kind of infer what's going to happen. If I was to write out all my w's and write out all my w's on bottom and top, I'd have 7 on top and 5 on the bottom. So then they'd cancel out. So rewrite this and we'll put 7 minus 5, which is just w squared. Okay, so that would be my final answer that I would box. That's the most simplified version. So then it also works with our negative exponents. So if I've got p to the 7th divided by p to the negative 3rd, I'm going to want to make these p's on the denominator, these ones, I'm going to want to make them positive. Okay, so remember when we're wanting to make exponents positive, we move them to the other part of our fraction. So if they're in the bottom, we're going to move them to the top. And if they're in the top, we're going to move them to the bottom. So here, we're still following the same rule. So p to the 7th minus a negative 3. Minus a negative means we're going to add. So this would just be p to the 7th plus 3, which is p to the 10th. Okay, so if I moved those other p's up top, we just say we're moving these 3 up to the top, that'd be 7 and another 3, so then I'd have 10. So p to the 10th is your final answer for that. Okay, so it also works when we have multiple variables multiplying on one term divided by the same types of terms, okay? So we've got our a squared, b to the negative 5th, that's our numerator. And then we're dividing by a to the negative 8, b to the negative 2. Okay, I'm rewriting them as fractions just because it's easier for my brain to visualize. Okay, so I'm literally just going to follow our same rule. So it's a squared minus negative 8. And then I have b to the negative 5th minus negative 2. And we'll notice something's going to happen with those b's here in a second, but I just want to keep following this rule of subtracting. Okay, so a squared minus negative 8 is going to be a plus 8, or 2 plus 8, which will be a to the 10th. And then you've also got a to the negative 5th minus negative 2, so we'll be adding 2. So that'll be b to the negative 3. I think I said a. It's b. Okay, you'll notice b is negative, so we need to move that term down, which we did before. Okay, so a 10, b cubed at the bottom now. And that's our final answer for that question. What you could have also done from the start is you'll see this is a negative 5 and this is a negative 2. Negative 2 is closer to being a positive number, so I could have subtracted negative 5 from negative 2 in the denominator. So rather than making it a numerator like I did here, I could have moved my b's to the bottom. But it's okay just to make them numerators first and then see what's negative at the end like I did. Okay, next question now has coefficients. So I'm going to rewrite them as a fraction. 18x to the 6th, y to the 6th, z to the 6th power, divided by 2x cubed, y squared, z to the negative 1. Okay, literally just going to follow my rules, except now we have numbers at the beginning, so make sure that you're still following that same thing of division. We know 18 divided by 2 is 9. We're not adding those numbers, okay? So 9. And then we've got x to the 6th minus 3, y to the 6th minus 2, z to the 6th minus negative 1. So instead of putting minus negative, I'm just going to put plus 1. Okay? So I've got 9x cubed, y to the 4th, z to the 7th. And that is my final answer for that problem as well. So now we're combining knowledge with what we did from last class. So we'll notice that we're now doing powers of a power in some cases. So here we've got d to the 5th over d squared. And then we're raising all of that to the power of 7. So first we need to kind of follow PEMDAS still. So can we simplify what's inside our parentheses? Well, sure we can. We just learned how to do that. So d to the 5th power divided by d squared is just d to the 5th minus 2. And then don't forget we're raising that to the 7th. 5 minus 2 is d cubed. If my stylus will write, there we go, to the 7th. Okay, now we've got powers of a power. So if I was to write d to the 3rd 7 times, I'd have d cubed times d cubed times d cubed all the way. And I'd notice I'd have 21 d's, so I'm just multiplying. That's one of our rules from before. That's powers of a power. So we just multiplied. So d to the 21st power is our final answer for that problem. Next, we move into something where we can't simplify inside the parentheses first. We need to make sure that we simplify our numerator first. So d to the 9th to the negative 3, we're going to multiply. It's just powers of a power. D to the negative 27 divided by v to the negative 4th. I know I just said d. I'm sorry. Now we're going to add our 4 to the top because we're going to follow that rule. So the negative 27 minus negative 4, which is just us plussing 4. So that'll be v to the negative 23. Notice it's negative, so we need to make it positive. Remember, we like positive people in our lives. So that is going to translate into 1 over v to the 23rd power. Kind of stepping it up a little bit, we've got a couple of different variables here in problem number 3. So we're just going to keep following our same rules. We've got v to the 3rd, g to the negative 4th, all raised to the negative 8th. So we're going to need to make sure we distribute this negative 8 to each of our terms that are inside, or each of our different variables. So that'll be f to the negative 24, g to the positive 32. Now we're dividing by our f to the 6th, g to the 19th. Okay, so now we're going to make sure we're following that same rule. We've got f to the negative 24 minus 6, g to the 32 minus 19. Okay, f to the negative 24 minus 6 is going to be f to the negative 30. And then 32 minus 19 is g to the positive 13th power. Notice our f is the only part that's negative, so that's the only one we're going to need to move. So it'll be g to the 13th on top, f to a positive 30 now in our denominator. And that's our final answer for that problem. Now we move into something even more difficult. We're now adding coefficients. Remember, we're going to need to kind of distribute this 5 to each term. So that means that not only are we distributing to the terms that have coefficients written, but we're distributing to our constants as well. So we've got 2, and you can kind of think of this 2 being raised to the 1st power. So now we're multiplying 1 times 5, which will be 2 to the 5th. And you can plug that in your calculator in a second. X to the 5th times 5 is going to be x to the 25th. This y is also raised to the 1st power, so that'll be 1 times 5, y to the 5th. And then lastly, z to the negative 15th on top for our numerator. Then we're going to do our denominator. Remember, we've got to distribute this 3 to every single term, including our constant. So our 3 raised to the 1st power is now going to become 3 cubed. X squared times 3 is to the 6th. Y is going to be to the 6th, and then z to the negative 3 as well. Now we can simplify that 2 to the 5th power, which is going to be 32. Then I'm going to go ahead and start subtracting my other exponents as well. So x to the 25th minus 6, y to the 5th minus 6, z to the negative 15th minus negative 3. And don't forget we've got our 3 cubed. Okay, let's simplify. 32 x to the 19th, y to the negative 1st, z, negative 15 plus 3 is going to be negative 12, and then 3 cubed is 27. Let's go ahead and make all of our exponents positive by moving them where they need to be. So we'll be left with 32 in our numerator and x to the 19th. And then we need to move down our other variables with our 27. So that'll be y. Now it'll be a positive first power, but we really don't need to write that 1, so I'm just going to leave y without 1. And then z to the 12th power. And that's our final answer for that problem.